The panel today, hopefully you have read and seen, come from a variety of backgrounds. I'm not going to give a long bio for all of them, but we've got something in common, which is this exploration about seeing the unseeable, and also how we are quite creative in our practice. So to introduce themselves, I've given them all a question to start with, and then we will take things from there. And the questions to start with, I'd like each of you to answer and have a couple of minutes to do so, is to talk about the types of research questions you pursue. So what type of research questions interest you? And also, how are you creative within that research practice? So I'll start with Emily, who...
Thank you, Rachel. Oh, okay. Hello? Okay. Right. So I'm Emily Howard. I'm really pleased to be here. I'm a composer, and I've long held a real love and interest in working with mathematical concepts and patterns. I have an undergraduate degree in mathematics and computer science, and then a PhD in composition. So the kinds of research questions I have relating to mathematics. I've written a series of works for orchestra. I love to write for orchestra, and they are orchestral geometries. And with each one, I've taken an abstract mathematical shape as a kind of imaginative cornerstone. So that can mean different things, and it certainly means different things in the different pieces. The first one I made is called Torus, and it's a donut shape. So you all know a torus donut shape. And when I was creating it, I was fascinated by the fact that thinking about the fact that you can travel this way around a torus and also into the torus, so two very distinct ways. And that really shaped the way I would think about musical questions. So it's as though this shape is a lens through which I'm thinking. So I might be thinking about how do the harmonies move? And how does the rhythm, how do I think about the rhythmic construction, and I think about things like the density of the orchestration. So it's not just the shape, is what I would like to say. It's everything through the shape, but I think about other things. For example, I love orchestral textures that are huge, lots of instruments playing all the time, and that gradually becomes an absolutely silent moment. And I love to do that. So I would work a way around thinking about this torus and think about ways to do that as well. So just another example, antisphere. This is a shape. It's kind of an imaginary shape. It's an impossibly real shape. I look at the mathematicians just check and correct it. But it's based, and it has a lot of. It's negatively curved, which means that if you take the angles of a triangle on a flat Euclidean geometry, we're told they add up to 180 degrees. But actually, on a negatively curved shape, it's shrunk and they add up to less than 180 degrees. So when I was composing this piece, I was thinking about the kind of what would happen if the chords that I use and every single musical parameter that I use is somehow responds to that and is shrunken in some way. So rhythmic patterns shrunken, chords shrunken, and so the piece is constructed again, thinking about these mathematical ideas very much at the forefront of the thinking.
Yes, I've done a lot of talks, some with Emily, about connections between maths and music, and there's always this kind of anxiety, I think, amongst an audience that, oh my gosh, they're going to take all of the emotion and drama out of the music because maths isn't that something very cold, logical, it's all about truth, and no kind of, where's the creativity in that? And I think to respond to your question about, what drives my research, it's actually the complete opposite. I think that what people don't understand is that a mathematician, I'm interested, how many people would count themselves as a mathematician here? Just to get a kind of, okay, good, that looks like sort of 50-50. So the mathematicians here will probably respond to this, but you see, I think non-mathematicians think that what we are doing as mathematicians is trying to prove all the true statements about numbers and geometry. And that is our role, So if you prove something's true about a set of numbers, then that's a piece of mathematics. One of my favourite short stories is a short story by Borges called The Library of Babel, which is a library which contains every single book it's possible to write. Now, at first sight, the librarian that runs this library thinks this library is fantastic because it's got everything in it. But then he realizes after a while it's got nothing in it because nobody's made any choices. And that's the important thing for me as a mathematician, are the choices that I make about the stories that I want to tell about numbers and geometry. And I do regard myself as a storyteller. It's interesting, we're now going to talk about connection between music and mathematics, because I think very often the journeys that I enjoy going on mathematically are, we're going to come to the idea of aesthetics, but for me, one of the things which is very important is the emotional reaction I have to the twists and turns of a mathematical proof. It's got, I've written quite a lot about creativity. I love Margaret Bowden's definition of creativity, a cognitive scientist. She said that creativity is something which is new, novel, surprising, and has value. And for me, it's those two other things. Surprise is about your emotional engagement. And that's incredibly important for me as a mathematician. The mathematics which I choose to, the research that I choose to do, has got to take me on some extraordinary journey which leads me somewhere completely different than when I started. I want it to be kind of moments of jeopardy, moments where I think something is going to go one way and it goes in a completely different direction. Those are the things which make the mathematics that deserves to be in the library that we put our mathematics in. And value as well. I think that ultimately I want to have a completely new vision on the world when I come out of my mathematical research and realize, oh my gosh, I didn't realize the world looked like this. Now, for me, the connections between mathematics and music is something that Emily and I explored in a piece that we worked on together, is that I feel that the aesthetic of that narrative journey that a proof makes shares a lot in common with the things I love about the music that I listen to. I fell in love with music and mathematics at the same time. My comprehensive school, my maths teacher opened the door to maths, which wasn't on the curriculum. My music teacher said, would anyone like to learn a musical instrument? Three of us put up our hands. We were taken into the storeroom cupboard, and there were 3 trumpets, so we all learned the trumpet. But for me, the two have always been on a trajectory together. But I really feel that the mathematics that I enjoy and the mathematics that I want to create, for me, has a very strong kind of musical narrative to it.
Thank you. Moving to music again, Lauren, tell us about your research.
So my name is Lauren Redhead, and I'm here really not because I'm only interested in music and maths, but I am interested in contemporary music and aesthetics, and I have written about Emily's music, so I've been interested in the relationship with mathematics that there is in her music. And in terms of aesthetics, I'm really interested in asking about the kinds of questions that contemporary music and contemporary art can ask, and how those questions might be different from or extend some of the repertoire of questions that have been asked in the history of aesthetics. So what are the ways that music and art propose different or new ways of thinking about the world to their listeners and to their receivers? And what are the ways that music and art offer people who listen to and encounter them different ways of thinking about being in the world? So this is really thinking about music and art as potentially as a philosophical practice, and the ways that artistic practices perhaps offer new and different ways to do philosophy, new and different ways to think about being in the world, new and different ways to encounter things. So I'm interested in how contemporary music can do that, the ways it might do that, and what it means for it to do that. And in Emily's case, that particularly has to do with that interface between mathematical ideas and concepts and musical sound.
Thank you. Moving on to Elaine, both musician and applied mathematician engineer. Do you introduce your research?
Hi, my name's Elaine Chu. I'm here at King's in the Department of Engineering and the School of Biomedical Engineering and Imaging Sciences. I started out in music and mathematics. Well, how far do I go? I come from a family of mathematicians, so everything was mathematics. everything in the world could be described by mathematics. So that was what I learned growing up. And when I was working on my graduate thesis, my PhD thesis, I was at MIT at the time, and I had the good fortune of also being appointed in music and theater arts to teach piano lab. And so this is the basic keyboard skills class that every student who takes a music module must also enroll in. And there are 1,000 of these students. MIT has a very large number of students taking music. And so, and any of them who had not learned an instrument, and there were not so many, but there were enough, had to learn keyboard skills. So I was teaching keyboard skills, and I would be teaching them how to play the piano. And they were like, how do I know how to play this? I'm like, you just have to have the key in mind. And they go, but what is the key? And so I thought, you know, of course I know what the key is. I don't even think, and my fingers know where to go if I know where the key is. And I can sight read very quickly as long as I knew what the key was. And so it got me thinking, what is it that I knew as a musician about the key? And how can I encode that knowledge mathematically, of course? And I was led to some research. At the time, I met Jean Van Berger, who taught me told me about this research that had gone on in the late 60s, early 70s in Edinburgh about early AI models of music perception. And so I was introduced to Mark Steedman's work and Longit Higgins. And so I looked at that, and at that time I was studying operations research, which is applied mathematics of a type. And I thought, well, I could do better than this, this model from the 70s. And so I ditched whatever else I was doing at that time, computational finance. And so I said, I'm going to now model music. And so this was how I began working on modeling music. It took me a while, a couple months, trying to figure out the geometry of the music. And when I figured it out, I came up with this model called the spiral array. And so I was very, very grateful and relieved that I was given a PhD for having invented the spiral array model. And so that was the end of my graduate school career. But then came the big challenge of trying to figure out who would give me a job doing this. And this was the year 2000. And the year 2000, luckily for me, was the beginning of music information retrieval as an area of research. And so there was a community to go into, and there was a place for my work to belong. But it still took me a while to get a job, because I would go and interview and say, look, this is what I'm doing, music and mathematics. And the departments would listen to my talk, and then they would say, so that was very cool. So what do you really want to do? And I said, no, this is what I want to do. So it took me a while, and eventually I got a job at the University of Southern California. And so this is how I started out. Just in an engineering school, because the engineers would take me. They took me in, and I was the only engineer in the Viterbi School of Engineering working only on music. So this is how I began. But more recently, I should fast forward to the present, because I worked on modeling music it's been over 25 years. It's been a while. And so now, more recently, about 9 years ago, I had my second cardiac ablation procedure for arrhythmia. And I saw all these signals, beautiful signals of hearts and ECGs. And I thought, data, mathematics. And this was when I was like, music, data, mathematics, hearts. And I began putting it all together, and I began turning heartbeats into music, transcribing them into mathematical musical rhythms and mapping them to music as a way to express what the arrhythmia was like. You know, like everything else in my life, it was mathematical too. And so mathematics was very important in expressing what the real world was like to me.
Thank you, all of you. And taking on what Elaine was talking about at the end, so this was a very concrete example of taking the heart signal, being inspired by that, seeing the data, and using your musical skills and your musical ability to translate that and almost see the unseeable in the heart through that music, which is, I thought, was absolutely fascinating. I think I'm probably going to turn back to Emily, though, with a question to say, you translate mathematics into music, but I think in a slightly different way to how Elaine has explained so beautifully to us.
Yeah, so I would say that, I suppose my aim is not to translate mathematics into music. It's more to take ideas from mathematics and to use them in a process to make music. And so I suppose perhaps the difference between what Elaine and I are doing, correct me if I'm wrong here, Elaine, but I feel that you're trying to make something so that you're explaining the science with a little, with the sonification, the making of what you're doing. Whereas I would say I'm doing almost usually the complete opposite of that. I'm using mathematics for aesthetic purposes. So, and it's alongside everything else. So I'm thinking of a piece of music I made where it's called Compass, and I'm in dodecahedral space, and I'm wandering around, and the mathematical process is one that we discussed, Marcus. That, I mean, if you move through it, you can move by twists of this dodecahedral space. You move into different kinds of flat geometries, or curved, or sort of negatively curved or positively curved, and so that shapes the way the music moves. There are, the musical parameters will change according to that. But it's not just that. The piece of music has been written for a particular percussionist, and I'm in contact with that percussionist, and I've explored personal sounds to them. I've also chatted a lot with Marcus about this idea. And so I think all of those things are adding to the mix of this. So when you listen to the piece of music, I would be very surprised if you heard anything like any of the mathematical influences in it. It's just that they are there, and so I suppose you can find traces of them, and I'm interested in the fact that what are those traces?
But I think what was so interesting is in our discussions, you see, I went and met Emily when Taurus was being performed in the Albert Hall, which is a beautiful example of a Taurus, actually, because if you just go round and round as an audience member, and just her excitement of exploring the geometry of this shape, the fact that you can independently go in different directions. I could hear the same kind of excitement that I, as a mathematician, have. I mean, it's one of my favourite shapes because of its, the fact that you've got these different paths, which mean you can create an incredible kind of algebraic structure on these things which isn't on a sphere, and you can use them to distinguish. I could hear the same sort of excitement of Emily exploring this shape as I have when I explore the mathematics of it. And that's why when we came to looking at other geometries that might be inspiring, for me this dodecahedron is, it's a bit like the game of asteroids, which some of the old people here are nodding their heads, which was this computer game that we used to play where you go off one side of the screen and you come on the other, and you go off the top, you come in the bottom. This is actually the universe of a torus, because if you join up all the pieces, you get a shape. But, I was very excited by this shape, which possibly could be the shape of our universe, which is a kind of dodecahedral shape where when you go out one face, you enter in another, but there will have to be a twist of some sort, and the different twists cause different shapes, geometries to appear. And for me, when I read about this, I thought, that's so beautiful, the idea. And it goes right back to the idea that Plato, when he saw the Platonic solids, used 4 of them for the elements, earth, wind, fire, and water, But the dodecahedron he was left with says, well, maybe that's the shape of the universe. And now we even have that as a, he wasn't thinking about it joined up in this way. But I think that's what's so, that the common ground is our common excitement over these structures, but we are exploring them with different languages, I think. So I just feel there's a resonance whenever we talk, that we're enjoying whatever these structures are. It's just, I will use a different medium to the one Emily's exploring.
I think I might push you a little bit further on this, Marcus, because what I'm hearing is the mathematics, these shapes, these structures, you're having a real shared excitement and interest. And this is impacting in a very deep way the music, the composition. I'm going to push you a little bit more, Marcus, because we've got quite a few mathematicians in the audience. How has your encounter with the music, do you think, affected your kind of mathematical discoveries? I can hear the shared excitement and enthusiasm for the mathematics, but is there sort of examples where the actual kind of outcome or music thinking?
I think it's probably hard to kind of explicitly identify, but my feeling is that these two worlds I grew up with from that early secondary school stage, and I do think the sort of things I enjoy mathematically have that kind of quality of, I love seeing an object which, as you manipulate it, can often turn into something completely different, or that you see two things which look completely different are actually two sides of the same equation, and just that joy of sort of seeing an intellectual journey that takes, and for example, one of my favorite theorems is by Pierre de Fermat, who says that if you take a prime, which when you divide it by 4 has remained a 1, so something like 41, Fermat proved that you can always write that as two square numbers added together. If my maths is right, that's 25 plus 36. It's 41, is that right? No, that's 16 plus 25. There you go. Mathematicians are useless at arithmetic, so I'm just really. But that's so beautiful, because why on earth should? And what I enjoy is the journey of that transformation. And I think I enjoy music where I see themes and ideas being brought together, fusing, arriving at some sort of. But the other important thing is in mathematics, it's very rarely. That's not particularly useful to know that those primes are written as sums of squares. What's fantastic is the journey to get there. And that's the kind of, and that's the strange thing, because, music has a temporal side to it. You listen to a piece of music. I think that mathematics weirdly also has a temporal side to it. Because when you read a proof, there is a sort of logical sequence of the argument, which almost feels like listening to something in time. And you can slow and speed that up as you go through the proof, but there is a kind of temporal development, I feel, in the way the proof takes you from somewhere comfortable to somewhere completely new.
I'm tempted to bring in Lauren here, I think. We've talked quite a bit about this experience of journeying through proofs, journeying through music, the interplay. I've also heard beauty being spoken about, and as mathematicians, we do often speak about beauty.
Did I say beauty at any point?
I think that there was a beauty. Did you say beauty? Someone has definitely.
I don't think I said beauty.
What did you say?
I'm very nervous about
it. Very nervous about beauty. Lauren, what's any thoughts from you about this? What you've just heard from their experiencing of the music and this inspiration that's shaping it.
Yes, well, I suppose what you're talking about there is also your empirical experience of the maths. So not that it's just a sort of abstract object that can be described or that's sort of hanging there to be encountered, but there's an actual human experience of that. And the word beauty can be a contentious word in aesthetics. It's a word that can be quite loaded when music and art are spoken about, because it can have some connotations of the past, of the 19th century, of conservatism, and therefore it can be a difficult concept to say, you know, what is beautiful? Is it subjective? Is that even a useful concept to help us to think about art and music? There was a composer, well, there is a composer still alive called Howard Lachman, who wrote an essay in the late 60s called On the Beautiful in Music Today, and he argues for the reconsideration of the term beauty and moving away from its kind of romantic connotations, rather to thinking about beauty as the culmination of striving for something, of trying to find something new. And that actually has a lot in common with the explanation of the proof that you just gave. So even though that might not be a day-to-day use of the term beauty in terms of people's discussion about music, it is an idea of beauty that exists within aesthetics. And I think that's quite an interesting parallel, perhaps, between music and maths. I certainly, in Emily's music, but in other music as well, I enjoy hearing a structure that can be a process that reveals itself. So that's something about the kind of temporal nature of music. It might not be something that concludes in the same way that we might think of perfect cadence concludes, but it's something that comes into view through the piece of music. And I think that's a journey of experience that one can have in music that I find a parallel with your description of the proof there.
I think that's why I like the word aesthetics, because it seems to encompass many more things than just the idea of beauty. I mean, I can get a lot out of a piece of music that it really is not beautiful at all, but that grittiness might be something that's transformative.
I'm going to come back to Emily. I think I'm not going up and down, but this human side, you just touched on. It's not just a piece of music; it's about our encounter with the music, and we're going to see different things and experience different things in that translation. Emily, when you go through this process of composition, aware that your audience is going to be interpreting and seeing this, what's the process for you? Do you kind of think, I wonder, this is what I want people to feel? Or tell us a bit more about this process of what do you see? What do you want the audience to see? How do you go through this process?
I always find this a very difficult question to answer, because it sounds... The truth is, I don't know that I mind too much, and I don't think so much about the audience as a general thing, because I don't think you can. And when I'm in, when I'm in flow, if you like, I'm thinking about all manner of things to do with reassessing the work of art every day, how bits might sound, why I don't think this bit works, and also the deadline or something like that. There are lots of things that feed into this, and almost never, in fact, never am I thinking, I wonder what the audience will think. Because some of them might love it, and some of them might hate it, and that's all fine. And I do think that the audience brings their own knowledge of everything they've ever heard and experienced before to that piece, and they will view it through that lens, and that's great.
And I'm looking now at Elaine. I'm jumping around here. It's fascinating hearing you, because I think, Elaine, we've not heard a lot about your current research, where you're actually, working with patients, you've worked with doctors, so you're very, very aware of those individuals who are interacting, with music, measuring. Maybe you can tell us a little bit, and the audience, a little bit more about that, and how you sort of view this interaction of the people, the music, the maths. I'd be interested to hear some more. I'm just putting these people on the spot. I've got this piece of paper here where I've listed lots of questions, and I'm just ignoring them. I hope you don't mind. So, go for it, Elaine.
All right. Okay, so where do I begin? My current project actually has to do with trying to express performance in mathematics. So much of mathematical modeling of music has focused on composition, and there is a lot that is added between when the composition is completed and when the audience actually hears it. And so the performer, who is the person in between, actually injects quite a lot more information into this transmission, of information to the listener. And a lot of this, the kinds of things that are added during performance are not encoded in the score. And so my research has focused on trying to extract these structures that performers create during performance and to represent them as objects, as concrete numbers, so that they can be analyzed. And in the process of looking at performers and what they do to music, I also then, one of the most natural things to come out of that is to then go on to see how what has been added here and what has been created during performance affects the listener, right? So our work on Music and the Heart has focused on how performing affects both the performer as well as the listener. What are these structures that are created during performance? How these structures, these decisions affect the person making them and playing the music, and how this also affects the listener. And what we've looked at, not just healthy listeners, we've looked at listeners who have cardiovascular disease. So we look at their heart signals because they're so beautiful. We look at the heart signals of both the performers as well as the listeners. And we look at the difference between people who are healthy and people who have heart disease or cardiovascular disease. So one of the groups that we've looked at first, we started we went off the deep end. We looked at people with pacemakers. And so these are people with mild heart failure. This proved to be slightly more challenging than we expected. So then we went to look at people with hypertension. And what we found is that people with hypertension and people without respond to the music structures differently. And so because they respond differently to music structures, so their cardiovascular signals concurrent with what's happening in the music as it's being shaped are different. They're statistically different. And so we are able to use this difference to diagnose hypertension just from the responses to music. And this is better than without music. So with music, it increases the accuracy of diagnosing hypertension uniformly across the board. It adds 10% to the accuracy. And we also, and if you try to pinpoint exactly what each person's systolic and diastolic blood pressure is, that actually doubles the R-squared that you get from the predictions. So this is what we've been able to do by taking music structures created during performance, plus the structures that are innate in the composition that have been created during the composition process. We combined these structures and we looked at the data of the person, recording the data of the person, their physiology, while they're listening to the music. And we built mathematical models of these associations and find the association patterns in order to use music in both cardiovascular diagnostics as well as cardiovascular treatments. Is that good?
Wonderful, thank you. Yeah.
I think there's an interesting two ideas which have come out of both of these responses, which I think really highlights a difference. I mean, I think we're always excited about looking at connections between maths and music, but I think as important is, but they are different things. And one is the embodiment. You see, music, you react, the body reacts. It's very important that it's an embodied experience. And mathematics is an intellectual experience, but less embodied. I mean, we don't have ears to respond. I mean, we try and develop in our students kind of mathematical ears to be able to, but I think that embodiment is absolutely essential difference between the two. The other one is Emily's response to your question about what you want the audience to feel. And Emily said, well, they can feel what they want. This is the idea of ambiguity, I think is extremely important difference between music and mathematics. You know, I think ambiguity is anathema to a mathematician. I want everyone to come to the same conclusion that those primes can be written as sums of squares. I don't want them to wander off, and I mean, I don't mind if they have additional ideas off the back of that, but the proof is meant to get everyone from from A to B. Whilst I think music allows, if you find yourself somewhere else, that's absolutely valid response. So I think the word ambiguity I always find is a sort of distinguisher between what my goal as a mathematician and when I perform my mathematics in my seminars or write it in my journals. I sort of want everyone to get the same thing by the end. And I don't think that's true in music.
I was going to butt in, but I'll let Elaine butt in.
I was going to ask, because the embodiment, the performance, and the embodiment of the performer as well as the listener, that could be mathematical too, but it could be very untidy mathematics, very messy mathematics. So the question is mathematics only aesthetic, and when it is neat and inevitable and all the same for everyone, or is it possible for ambiguity to be also mathematical?
So I was going to jump in. I'm allowed to jump in and pretend to be a panel member and talk to the chair. So Marcus, I'm wondering if I would beg to differ on the ambiguity in maths. So as well as Cho, I'm a mathematician, but very much at the kind of applied end of mathematics. And for me, quite a lot of what I do is kind of working out what sort of approximations, and there's probably and in often cases.
That's why I don't like your end of mathematics. Yeah.
But I think it's an equally valuable.
No, exactly.
aspect of
I think you're right. This is about aesthetics.
And it's this question of, if we want to make a mathematical model, a mathematical approximation, what are the assumptions that we want to make that are going to help us answer the questions? And there's the choice aspect, and the choice in that case might be influenced by our conversations and our discussions with scientists and the discipline that we're trying to model to work out, what is it that they most care about. So maybe there is less of a gulf between those two disciplines when we think of.
But I think this is very interesting about the different choices of mathematics that we wanted to go. You see, I just hated all of that, approximations, things like that, just like, so I wanted things where I really could arrive at genuine truths of the universe and revelation. So for me, I think that again may have been driven by also the sort of music I love.
On this one, right? Moving away from the divisions in mathematics, where do we go from here? Emily, so tell me a bit more about your conversations, your relations, and the way you get inspired by conversations with wonderful people like Marcus on the mathematics and others. How does this take you in your journey of music? Because I think one of the things I have had the privilege of working with you is your real genuine interest in the depths and curiosity of the mathematics, but then you take it in a very different way. So in these conversations with mathematicians, what is it that you're kind of getting out of that and enjoying and appreciating from those conversations?
Okay, so I'll just say something about our first collaboration, which actually was around nearly 10 years ago. We worked together, we met at the Royal Albert Hall about thinking about the torus. But in fact, we worked together on something called the music of proof. And for that, Marcus was looking at different kinds of mathematical proofs, and he asked if I might be interested in making some responses to the different kinds of proofs. Mathematicians can prove things in various different ways. We've got proof by contradiction, we have proof by induction, there's a conjecture in there as well. And so I did this in collaboration with Marcus, but also in collaboration with the Piatti String Quartet. And I think I had a research question, something like, what would it mean to try to enact a mathematical proof in music? And unlike those freer pieces, I call this, it's a bit like an etude, it's like I really wanted to try to stick as closely as I could to this proof as best I could. And so I also, again, lots of personal things come into this. I mean, I'm a huge lover of the string quartet and the string quartet repertoire. I went to the string quartet and asked them some of their favourite pieces, and I use these as points of departure. There's Haydn's first published string quartet, and I think there's something from Schubert's definitely. There's all older stuff, because I wanted it to be older stuff as well, so that it would be quite clear when I'd come out of it into my own language. That was another idea. And so we could just talk through proof by contradiction. Do you want to just kind of explain?
Yeah.
And you explained many times. It was really a pleasure and a great honour to have Marcus writing these things down for me lots of times, even though I'd done them. I think they're A-level maths, aren't they?
Probably, yeah. Certainly. This was a kind of exercise in this feeling I had that the aesthetics of mathematics that I enjoyed of proofs had a musical quality to them, and I think our conversation sort of, for me, was. Has this got any credence for you as a composer, that these proofs, do you feel they have any kind of musical quality to them? So I took, I sort of went back to where proof just started, which was Euclid's Elements, and took some of the beautiful proofs that are in there, including proof by contradiction. So this was to prove that you can't write the square root of 2 as a fraction. And it starts beautifully. Suppose you could write it as a fraction. And then you just tease out what that would imply until you get to a point where essentially you prove that an odd number is even. You get to a contradiction. And I thought this, it's a classic move in the mathematician's arsenal, is to try, well, if I'm trying to prove something, what if I suppose the opposite? If that takes me to a contradiction, then I can assume that the thing that I started with was actually true. So I was kind of intrigued. What on earth resonance would that have? What does it mean to suppose the opposite? Does that mean anything for a musician? So that was kind of the fun, beginning of the conversation we started having.
Yeah, so just to carry on from that, so this is something that I've done many times myself, and yet actually it took this conversation. So that was the creativity from Marcus, or something to spark it. But then actually, I suppose, suppose the opposite. So obviously, actually, every composer anywhere, we'd all do very different opposites, and that's part of the joy of this. I started with, I think I started with a part of the Haydn, and I thought I would try to get, I thought rather than take Haydn's journey, i.e. the piece, because of course there is no such thing really as mathematical truth in music. So I thought I would retrofit this. So I thought, suppose the opposite, what would the opposite be? So I thought, rather than this very neat piece of music, it's kind of central register, everyone's playing, I thought I'd have this thing, it goes on forever, it's kind of it reaches this complete mess. And I also put in the score, repeat ad infinitum, I think. So it goes on.
The thing just gets faster until the quartet crashes. It just, it can't be done.
But we assume the opposite bit. Before that, I assumed the opposite of this little piece of Haydn. That was a really interesting exercise, and it has led to me just assuming the opposite whenever I feel like it now. So it is something that I did, and it will be, have everyone playing it in different times. It was very, very asynchronous, and it did get faster and faster. And then, as I said, it reached this point, kind of this contradiction, if you like, from the other bit, and then explodes, and there you go.
Fantastic. Lauren, I can't remember now, was it one of these pieces, the proofs ones, or one of the others that you wrote about Emily's work? Or maybe you can comment a bit on Emily's work from your perspective, because I think you've had some fascinating insights exploring it from that kind of musicologist perspective.
So I wrote about an opera that Emily has written called To See the Invisible, which is very similar to the title of this session, but I also looked at some of the orchestral geometries and some other recent pieces where Emily's also collaborated with other artists as well. And I think that's a really fascinating example of what is the opposite and how does that function. And I think it's interesting for two reasons. The first is it shows the productive relationship of this way of thinking, which isn't just about making music that somehow represents or explains, but it's actually that collision or interpolation between music and maths has actually produced a way of thinking about and doing music that is also unique and new. So it's something else has come out of that relationship that wouldn't have been there without that question. And I'm also interested in how, probably the easiest way to say it is how can music be a part of the kind of speculation of these ideas. So we were hearing a few moments ago described geometries that we can't see them. They're not something that kind of exists in the world that we can go and look at and explore. So one way of exploring them could be to describe them mathematically. The music that Emily has written is another way of exploring them. It's not exploring them so that we can understand how to maybe describe that to each other in words, but rather it's understanding what an encounter with these ideas might be, what a way of thinking through them or thinking with them might be. And in doing that, this is not only an encounter with the mathematical idea, but you mentioned the performer that you were collaborating with, or the orchestra, there's always something more. So if I wanted to say it in more philosophical language, I would say this music always exceeds its signification. So it doesn't just represent the mathematical idea, but there's already more things. There's the sound, there's the instruments, there's the performance and the interpretation when the music is played. And so that encourages or allows the listener to enter into a dialogue with those ideas, which isn't just a dialogue that's about understanding them, but it's potentially a journey that takes the prior experience of the person who's listening and the music that's written by Emily and Emily's prior experience that has coloured the decision making in her composition, which can create new meanings which might be individual for each of us, which might be shared for many of us. So if all of us in this room were listening to some of these pieces, we probably have a lot of shared cultural experience that we bring to those experiences, and that's how we can share experiences about music and art. So in this context, mathematics doesn't only offer something to be understood, but also it offers a form of inspiration that is productive, that goes on to create new meanings, new ideas, new experiences, and music is one of the media in which it can do that.
Thank you. I've just had my 5-minute warning, so I think to wrap up, I think a sentence or two from each of you, perhaps addressing the question, what does seeing the unseeable mean for you? Or if you've got anything else that you're burning that you have to get out there. Elaine, do you want to start?
Okay. I guess my work started with trying to make visible the unseeable feeling of what harmonies and tonality were. So my model is geometric. You can see it in 3D space. You can see it working. You can see it analyzing, evolving with the music. So it's a way of turning something that may not be easily perceptible, at least not as perceptible as rhythms, into something concrete. Same thing with the heart example. What I've done is actually take something that is, again, not visible. Arrhythmia is not easily visible. You can't tell if someone's having an arrhythmia. But I've turned it into music where you can actually feel what it feels like. Arrhythmia music is very uncomfortable. It's just like the arrhythmia itself. It's not something to relax to. Most people tell me how distressing it is. So it's a way of turning concrete again, something that is invisible.
I think for me, to see the invisible is to have that aesthetic experience or aesthetic encounter through music or through art that is about having an experience that's outside of everyday experiences and having an experience that may not be translatable into written or spoken language or other modes of communication. So it's about having that moment of experience that belongs to or comes from music that feels inspirational, that feels like you are able to think about things in a different way, even if those thoughts can't be put into words.
I'm a very unvisual person. And my wife, who's an artist, kind of thinks I'm completely blind visually. And I think it is because I use my ears really as my way of navigating. If I had to sacrifice my sight or my hearing, I would sacrifice my sight. So for me, the aural is how I navigate the world. Now, my area of research is symmetry, which sounds incredibly visual. You think of the Alhambra or Escher or symmetrical. But what I do is to try, my greatest discovery, which I'm proud of, is the discovery of a symmetrical shape in very high dimensional space. Now, I fell in love with symmetry because in the middle of the 19th century, mathematicians found a way to go from the visual to the linguistic. And for me, language is where I feel much more at home. And so I use this language of algebra as a way to create shapes that I'll never be able to show you this thing, but I can help you navigate it. And almost that language is, you spend so long in this world, you start to think you're seeing in high dimensions. And my feeling is that music, if you draw a diagram of something, the best you've got is 3 dimensions. You might be able to put maybe some color on it or something, but there's a limited number of dimensions that you can work in visually. But orally, my feeling is, and I'm not sure whether this is true, but that there's that you can actually hear higher dimensional shapes probably more easily than you can ever see them. And so this is something that Emily and I are beginning to explore to investigate, what sort of level of kind of dimensionality can one realize in music. And so can you use music in the same way that I've used group theory and algebra to hear, feel, encounter things which you'll never be able to see?
I mean, just more of all that. Really. Yeah. Absolutely, to see the invisible. I mean, it's to do with exploring these aural landscapes and responding to imaginary things, really. But I just wanted to pick up on something that we said. It's to do, for me, it's a collision of disparate ideas and the sort of merging of them, and in a sort of impossible space in my brain. I really enjoy that. So there always seems to be something mathematical. I'm very drawn to this, but it's the merging with something from the collaborations around me, something else from the performance in taking part in this acoustic music, and the situation, it's the kind of merging of all of those things. And I know when it connects, but but it is invisible.
Thank you. Thank you so much. We are at the end of our time, but I hope you will all agree what fascinating insights and thoughts. I suspect you've got a whirlwind of things happening in your brains, not all of which you can express in words. Thank you so much for coming, for your attention, and let's thank the panellists for a fascinating